Hi, this is Dave Johnson with another edition of Math Off Topics. I want to start a series on polynomials and probably have maybe 3 or 4 videos on that subject. This first one is going to be how the leading term dominates the end behavior of the polynomial. I think polynomials are important whether you're taking algebra or pre-calculus or any of the calculus courses. I find that students sometimes get confused about the behavior of polynomials. And yet polynomials are so crucial to our understanding of uh, any kind of math, especially higher level math. So let's get into it. So I've written up here a general form for a polynomial, and I'm using P to remind you that it's a polynomial, but you could use f of x if you are more comfortable with that, q of x, whatever you want to call it. And you can see that it's made up of terms. The polynomial is poly, meaning many, nomial. So a binomial would be 2 monomials, trinomial, and so on. We even consider a monomial to be a polynomial. So first term, second term, additional terms, second with the last term, and then the constant term. And so this we call the leading term because it has the highest degree of, of all the terms. So n in this case, n minus 1 is smaller. And you write them usually in descending order by degree. So this is the nth degree term, this is the n minus first degree term, and so on. This is the first degree term, the linear term, because there's a 1 here which is not written. And notice the subscript on the coefficient is the same in this case as the degree. And then, of course, the constant term, which we call a sub 0. A lot of us old timers, we call them a naught. Naught is just another word for nothing or 0. So, and let me give you an example of a typical polynomial. So p of x is, let's say, 3x squared minus 4x plus 1. So that's a quadratic second degree polynomial. Second degree because the highest degree term has degree 2. This is degree 1, and the constant term is degree 0. So all polynomials can be written in this as a sum of terms. They can also be written in factored form, but that's a discussion for another video. And you don't have to have all the terms. You could be missing one of the middle terms. You could be missing the constant term. But whatever the leading term is, that determines the degree of the polynomial, and you can't be missing the leading term. That wouldn't make any sense. So now I want to talk about end behavior. What do I mean by end behavior? Well, end behavior is the behavior of the function, in this case, the polynomial, as x gets very, very large in the positive direction or very, very large in the negative direction. So in other words, as x goes to positive infinity or x goes to negative infinity. And they can have different behaviors in those 2 different directions. So, and I want to have a lengthier discussion about end behavior in another video, but here we're trying to understand why the leading term dominates the polynomial. And what I mean by dominate in this case is the leading term dictates the end behavior of the polynomial. Now, why would that be true? Well, I'm going to show you. So let's take our p of x, and what I want to do is I want to factor out the first term. In other words, I want to factor out a sub n times x to the n. So let me write this. P of x is equal to a sub n x to the n times, and then we're factoring, so we're removing that a sub n x to the n. So from the first term, we just get a 1 plus, and then I'm going to write it this way: a sub n minus 1 x to the n minus 1 divided by a sub n x to the n plus, and then there's more terms, dot, 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 plus, and then let's say a1x divided by a n x to the n, and then plus the a naught divided by a n x to the n, and then close the parenthesis. So we have factored out the first term of the polynomial. Now your math teacher, if he or she has talked about polynomials, may have written this, may have just said it, may have assumed that you read the book and saw this in the textbook, but I wanted to go through it, and we're going to break this down into more detail and see exactly what happens so that you really do understand what's going on. Because that's the goal. That's my goal in these videos, is to help you really understand what's going on. So if, let's say, if x goes to infinity, and it really, in this case, well, it matters if x goes to positive infinity or negative infinity. We're going to talk about that in another video. But let's suppose that x goes to infinity. What's going to happen? Well, I want to rewrite this to make it a little clearer what's going on. So p of x is equal to, again, a sub n x to the n times 1 plus, and now I'm going to break out the coefficients here. So a sub n minus 1 over a sub n. And then if you take x to the n minus 1 divided by x to the n, you get 1 over x. Because n minus 1 minus n, if you subtract the exponents, the n's cancel and you get minus 1. So x to the minus 1 is the same as 1 over x. Plus, dot, dot, dot. So we're doing this for all the terms. And then same for the linear term, a1 over a n. And then x divided by x to the n, well, 1 minus n. So we're going to get 1 over x to the n minus 1 downstairs. And then plus, and we've already got it, basically a naught over a sub n times 1 over x to the n. And I'm almost out of room there. Okay. Now what happens? Well, if we can think of it as a limit, if you've had calculus, you'll know what I'm talking about. But if you haven't had calculus, don't worry. If you're taking algebra or pre-calculus, this is still going to make sense. As x gets very, very large, so it goes to infinity, the 1 over x is going to get teeny tiny. It's going to go to 0. And usually I indicate that by drawing an arrow pointing at 0. Well, all of these are going to go to 0, including this last one, because 1 over something that's huge, even if it's to a power, positive integer power, that ratio, that fraction, is going to go to 0. And so what you end up with is a sub n x to the n times 1, because all the other terms are 0, and that's the result. And so whatever the behavior of a sub n times x to the n is as x goes to infinity, that is going to be the same as the behavior of the entire polynomial as x goes to infinity. And it turns out it doesn't matter in the case of a polynomial. We get the same result even if x goes to negative infinity, because those fractions will still go to 0. So that proves that the leading term dominates, because remember, a sub n x to the n is the leading term. So if x gets very, very large in either the positive direction or the negative direction, the behavior at those places, positive infinity or negative infinity, are controlled, dictated by the leading term. So we'll talk more in another video. I hope this has been helpful. If so, please like and subscribe, and I will see you in the next video.